Okay, the goal on this problem is to find the slope of the tangent line to the curve, and then we have an equation at this specific point, 3, -1. So to do so, we're going to use implicit differentiation to help us out. So I'm going to go ahead and zoom in here. We'll take a look at this and get a plan together as we get going on taking the derivative for implicit differentiation. We'll kind of do this one term at a time as we go through it, and hopefully explain out all the steps so it makes perfect sense. So the first term, the 3x squared, we're going to go ahead and just use the power rule in this case because we have a single variable. We can bring the exponent down, multiply it by 3, so 2 times 3 to get that 6, then reduce the exponent by 1, so this will be x to the first power. Now that second term is a little bit more complicated. We have 2 variables here, so I'm going to treat this as though it's 2 separate functions being multiplied together. So I'm going to treat the first one as though it's f multiplied by g. All right, the f being -2x and the g simply being y. So to accomplish our goal here, what we're going to need to do is use the product rule. So writing out the product rule, it's going to be f prime times g plus f times g prime. All right, now that we have a plan in place, let's take our derivative one step at a time. So the derivative of -2x, because it's linear, is going to be -2. And because our variable was x, we don't need a dy dx next to this or a y prime. Next, we want to fill in, we're multiplying by g, which in our case is just going to be y, plus, now we need to copy down our f. Now our f is -2x. We could make that subtracting 2x in the middle there. I simply just put my addition sign in between and copy down what I'm treating as our f function. All right, next we need to take the derivative of y. Now the derivative of y is going to be 1, but because our variable this time was y, we need to include either a y prime or a dy dx next to this. I'm using y prime for notation's sake on this one. All right, moving on to the 4y cubed. Again, power rule for this one is going to be bring the 3 down, multiply it by 4. So that's going to make 12. Then we reduce the exponent by 1, so our new exponent is going to be a 2. But again, we have to remember we just took a derivative. This time our derivative was with the variable y, so we should include either a y prime or a dy dx next to that. Finally, taking the derivative on the right-hand side, we have 29 over there. That's a constant. The derivative of a constant is going to be 0. All right, from here, let's go ahead and begin isolating the y primes on one side by themselves. All right, so in order to do this, I'm going to go ahead and move the 6x to the other side. So I'm going to subtract 6x from both sides. That'll eliminate these from the left-hand side. Then I also want to move the 2y term to the other side because neither one of those terms have a y prime with them. So to move that to the other side, we'll add 2y. Same thing on the right-hand side. And that'll eliminate that term from the left-hand side. All right, let's rewrite what we still have on the left-hand side. I'm going to write this as -2x y prime. Kind of drop the multiplying by 1 in the middle there because that doesn't really change what we have. Plus 12y squared y prime. And then on the right-hand side, we can either write this as -6x plus 2y or 2y minus 6x. The order doesn't really matter there. All right, as you work through these, you're going to notice a lot of times you get to kind of the same place where you've isolated all the y primes on one side, so that'll become a common factor for this side. So we'll factor that out and think to ourselves, y prime times -2x will give us the first term, and y prime times plus 12y squared will give us that next term. Okay, from here, we've made it so that we have y prime multiplied by the entire left-hand side. To get y prime all by itself, we're going to have to divide the entire left-hand side and the entire right-hand side by -2x plus 12y squared. All right, so that's putting the y prime on one side all by itself. All right, so this is the derivative to that curve that we were given, that equation. with respect to x. Now let's take into account we wanted to find the equation or the slope of the tangent line to this curve at this very specific point. So when they give us this point, that's an x value and a y value. So we're going to plug into our function here, and where we see an x, we're going to put a 3 in that spot. And where we see a y, we're going to put a -1. All right, same thing in the denominator. -2 times where we see an x, replace it with that 3. Where we see a y, we're going to replace it with -1. From here, it's a bit of simplifying down, but shouldn't be too bad. We have -6 times 3 is -18 minus 2 over -6 plus 12. And then -1 squared makes +1, so that'll still be a plus 12 there. All right, to finish this up, we get what? -20, combining our like terms in the numerator, and 6, combining our like terms in our denominator, which will reduce a little bit. Those are both multiples of 2. So we could say -10 over 3 is the best answer we can get to for the slope of our tangent line at that very specific point. All right, hope this helps out as you're working through learning about implicit differentiation and finding slopes of tangent lines, which are, of course, the same thing as the derivative evaluated at that specific value. All right, good luck.